Researchers at MIT have developed this game that artificially lowers the speed of light throughout the gameplay, and this allows us to visualize the effects of relativity, the crazy effects of relativity. Just a little warning though, that this game and therefore this video may trigger seizures for people with photosensitive epilepsy or motion sickness, so if you feel sick at any point, please just stop the video. Okay, now let's have a look at what the game is like. So I'm gonna click and continue. Credit to the MIT Game Lab, by the way. This is really interesting. So I'm gonna click play and let's see what happens. Even a little bit of a story. So we need to collect orbs, and as light gets slower you will start to see beyond what humans can typically see. That's really interesting. So they've already programmed in the relativistic Doppler shift. Okay, so now that we know what the controls are, let's have a look. Okay, so initially I'm looking around and things seem relatively normal, so no big changes. However, with every orb that I collect, the speed of light will get artificially lower. So you can see a counter on the lower left hand corner, and every time I collect an orb, the speed of light gets a little bit slower, and there's a little tracker on the right hand corner as well. Even now I can still see some effect. So if you look closely, if I was to move back, you can see some changes in color. This is the Doppler shift that even now it's starting to take place. So let's collect a few more of those. Let's see whether we can notice a few more effects. So I'm currently on 7 orbs. Okay, let's lower the speed of light considerably. So 9, 10. This is actually getting pretty hard to move around. This is because, of course, of the Lorentz transformation. So I'm experiencing some length contraction and other relativistic effects. With every orb that you collect, you can see that the colors are changing significantly. So we're on to 18. We can collect quite a few more. Let's see what happens. Let's collect this one and this one. So we are on 26 orbs at the moment. Just look at that. So if I was to move back, I can notice a definite change towards the higher wavelengths. If I was to move towards an object, I can definitely see that the colors are shifting towards the ultraviolet. So in a way, this is an ultraviolet shift. Okay, we are approaching 50 orbs, and we can see that the effects of relativity are really starting to get a little bit crazy. So the actual Lorentz contraction is super visible. Just have a look at the size of one of the rocks above. If I was to look at it and start going towards it, you can see the size definitely changing. If I reverse back, the size is changing yet again. Now notice the actual colors of the wavelengths that I see. If I was to move forward, everything is getting shifted towards the ultraviolet, and if I move backwards, everything is getting red shifted. Now let's see if we can collect a few more orbs. I'm only about halfway, so the effects of relativity should get even more spectacular as we are moving across. It is actually fairly hard to collect those, simply because the spatial awareness in a way is changing considerably. Oh, look at that effect. As soon as I move forward, everything is getting shifted towards the ultraviolet, and that's a lot of orbs, so I'm expecting a huge amount of change. Just look at that as I'm collecting those. Whoa, look at that effect over here. So now the speed of light is lowered considerably. I'm on about 65 and I've completely missed this one. Okay, let's try again. I can imagine that soon I might be even outside of the visible range, which would make things very difficult indeed. Let's collect this one. Now notice once again, if I was to move back, everything gets completely redshifted. So look at that, how spectacular this is. This is what we're observing when we observe distant galaxies, because they are moving away from us. Okay, so I'm on 74 and the speed of light is very, very low indeed. And the effects are going absolutely crazy. Just look at the size of this house. And if I was to move back, that changes considerably, which makes it kind of hard to pinpoint your exact location. And everything pretty much changes as soon as I was to accelerate forward. And this is what we would expect to see if we're in a spaceship and we're moving at about half the speed of light. So this is going to be really interesting. There's quite a lot of orbs to collect, and there should be some very, very significant effects. So let's see if I can manage to stay in one line and collect them. So moving on, we're on to 82, and look at that, just shifting towards the ultraviolet. And I think I can actually see the time effect now. So what I'm seeing now no longer corresponds to what is actually happening, because the speed of light is so low now. Let's see whether we can collect the last few orbs. Notice something as well, which is really, really interesting. So you pretty much can't see anything different when you're completely stationary, but as soon as you just gently move forward, everything changes. Now this is the equivalent of, once again, what we would see in a spaceship if we're moving at over half the speed of light. So I've collected another one, so I'm on 92 and the speed of light has dropped even more. Let's see if I can squeeze in and collect a few more. And I'm on 94. Let's see if we can go up to 95. The length contraction, or the Lorentz transformation of space-time, is so apparent right now. So pretty much everything changes and space-time kind of warps as soon as I move forward. And I'm on 97. And moving on, let's see if I can collect one more. 98. Notice something really, really interesting. So if I was to move back, then almost all of the wavelengths that are being emitted are now outside of the visible range. So humans can only see wavelengths between sort of about 400 to about 700 nanometers. So now they're shifted to much longer wavelengths that are outside of the visible range. So a lot of the wavelengths that are being emitted are actually going outside of the visible spectrum. So if we are in a spaceship and we're moving away from something at sort of more than half the speed of light, we're going to see something like this. Now on the other hand, if we're to move towards something, we've only got 2 more orbs to collect. We are going to see this. So let's avoid this guy over here, and let's collect one more. Like so. So it's 99, and our last one with our last relativistic effect, and 100. So we've done this in about 11 minutes and 20 seconds. You can actually download this game and have a play yourselves, thinking about the laws of relativity. Thanks a lot to the researchers at MIT who have taken some time to code the exact physics of relativity into this game engine. Absolutely fantastic piece of coding. Thank you very much for watching, guys. Hopefully you found this interesting, you've learned something, and I'll see you in the next video.